Rules for picking a protein for expression when you're conducting expression studies. So protein size influences the level of difficulty you will have in its expression. Other limitations also exist, such as the location, if it's a transmembrane protein, or how soluble the protein is. So let's take a look at some of the rules. In general, protein sizes that are quite small, so less than 20 kilodalton, are easier to express in E. coli, and this is due to their simplicity in folding requirements and reduced likelihood of aggregation. However, they may require fusion tags for stability and detection during the purification process. The sweet spot for protein expression tends to be proteins that are between 20 and 70 kilodalton. These proteins are often ideal for expression in most systems. Generally, the systems for protein expression include E. coli, yeast, and insect cells. So many structural studies do use the proteins that are in this size range due to their solubility and manageability in terms of their folding requirements. Proteins that are greater than 70 kilodalton tend to encounter challenges when they are trying to fold. You tend to get misfolding, you get aggregation, you get inclusion bodies, and so these systems are definitely not useful for expression in E. coli, but you can co-express these proteins with things called molecular chaperones or by optimizing the codons, and these tends to improve the amount of soluble product that you will get. Host systems like yeast or mammalian cells may be better suited when you have any protein that's above 70 kilodalton, and that's because these proteins can handle complex folding or post-translational modifications. Proteins that are considered very large are those that are greater than 150 kilodalton. These proteins are definitely not suitable for E. coli, again due to folding and solubility issues. In such cases, insect or mammalian expression systems are your preferred option. Systems like baculovirus expression vector system, BEVs, or CHO cells or HeLa cells may be a better option for such large proteins. So, membrane proteins. Membrane proteins of any size tends to give issues. So they pose unique challenges because of their hydrophobic domains. They need to have part of their domains in water exposed, fluid exposed areas. And so expression strategies often require special detergents as well as co-expression with accessory proteins or host specific adaptations. Or one strategy is that the researcher may just express the soluble fragment and study that and not worry about the insoluble fragment. So the next step will be to look at websites. They're called databases for downloading the nucleotide sequences that will allow us to insert into a plasmid so that we can get expression of this protein in E. coli or yeast or an insect expression system depending on the size of the protein.